We have established that there is a scientific consensus that human-induced climate change is happening, but we need to address the question of how this was established. In this, I mean, what was it that convinced the scientific community to take such a consensus position? What are the observational data and computer modelling that is so persuasive? There are a number of questions that need to be answered. First, does the observational record show that average global temperatures are rising? Second, is the temperature rise unusual? Third, are atmospheric greenhouse gas concentrations also increasing? Fourth, is the rise in carbon dioxide due to the burning of fossil fuels? And finally, do we understand human-induced climate change? Let's consider the instrumental average global surface temperature record. The first issue that we are faced with when looking at the instrumental record is which instrumental record? There are 4 major keepers of records on global temperature. From the United States, there are the NASA and NOAA datasets, but there are also datasets from the United Kingdom and Japan. In general, the datasets agree, but there are small differences as illustrated in this figure. Note that a 5th dataset from Berkeley Earth is also included. These datasets use the 1951 to 1980 period as the baseline for temperature change. The average pairwise correlation between the 5 datasets illustrated here is 99.04%. But why don't the 5 datasets agree perfectly? The answer to this question lies in the nature of the sources of the data used in these constructions. The data used in these constructions are collected at thousands of meteorological stations, buoys and ships around the globe. The longest running temperature record is the Central England Temperature Data Series, which starts in 1659. However, the longest running quasi-global record starts in 1850. Although all 4 major datasets have strong similarities in how they track and analyse temperatures, there are subtle differences. The NASA record tends to run slightly higher than the Japanese record, while the United Kingdom and NOAA records are usually in the middle. There are good reasons for these differences, small as they are. Getting an accurate measurement of air temperature across the entire planet is not simple. Ideally, scientists would like to have thousands of standardised weather stations spaced evenly all around the Earth's surface. The trouble is that while there are plenty of weather stations on land, there are some pretty big gaps over the oceans, the polar regions, and even parts of Africa and South America. You can see the global climate network of temperature stations here, coloured by the length of station record. The 4 research groups mentioned above deal with those gaps in slightly different ways. The Japanese group leaves areas without plenty of temperature stations out of their analysis, so its analysis covers about 85% of the globe. The United Kingdom Met Office makes similar choices, meaning its record covers about 86% of the Earth's surface. NOAA takes a different approach to the gaps, using nearby stations to interpolate temperatures in some areas that lack stations, giving the NOAA analysis 93% coverage of the globe. The group at NASA interpolates even more aggressively. Areas with gaps are interpolated from the nearest station up to 1,200 kilometres away and offers 99% coverage. Beyond these issues of coverage, the surface temperature record also goes through a series of adjustments to correct for issues such as missing data, changes in instrumentation, movement of stations, and human or technical error. This process is known as homogenization, and despite being a well-understood scientific practice, has been used by some climate skeptic commentators as evidence that scientists are fiddling the data to overstate the amount of warming we've seen. You might argue that we have satellite data, so why don't we use that? Surely it would avoid these issues. The first issue is that satellite data only goes back to 1979. The second issue is that raw satellite data has to go through a far more extensive adjustment process. Satellites do not directly measure temperatures and are subject to large systemic biases due to orbital decay, diurnal sampling drifts, changes in the satellites used. There have been 13 or so different satellites since 1979. Correcting for these biases is not straightforward, and different choices in correction parameters can lead to different trends during the period from 1979 to the present day. So those are some of the technical issues in constructing the instrumental average global surface temperatures and why we rely on the surface network of measurements. So has there been a temperature rise since pre-industrial times? Well, the figure we showed previously had as a baseline the 1951 to 1980 average and showed a temperature anomaly of between 0.75 and 1 degree Celsius, depending on the dataset. Arguably, the effect of industrialisation is already present in the baseline average. If instead we use the 1850 to 1900 period as a proxy for pre-industrial temperatures, then the temperature rise is even greater. The Berkeley Earth dataset here gives a temperature rise a little in excess of 1.2 degrees Celsius. The IPCC in the 6th assessment report reports this temperature rise as 1.1 degrees Celsius. The observational temperature record does appear to confirm that global average temperatures are increasing. Thanks for listening.